Hello students, welcome back to the physics sessions. In the previous video we have finished the numericals from the second lesson, that is work, energy and power. Today we are going to start with a new lesson, that is lesson number 3, machines, numericals from that lesson. Before you start with this video, I want you to go back to the previous videos and solve that numericals carefully, and then we'll start with this chapter. As you can see, a diagram I have drawn, that is for the question number 1. The question is given like this: a crowbar of length 120 cm has its fulcrum situated at a distance of 20 cm from one end, from the load actually, and calculate the mechanical advantage of the crowbar. So as you know that crowbar is a class 1 lever, so I have drawn here. So fulcrum is at center. From the load, fulcrum is at 20 cm and total length of the crowbar is 120 cm. So load arm L to F distance is 20 cm, and here effort arm, that is E to F distance, will be 120 minus 20, that is 100 cm. And you know that mechanical advantage for any class of lever is effort arm upon load arm. So it will be EF upon LF. So EF is 100 cm, LF is 20, so the value will be 5, and there will be no unit to it as it is a ratio of same quantities. Okay, just pause the video and write it down carefully. Now we will solve next question, that is question number 3. So a pair of a scissor has its blades 15 cm long. Pair of a scissor has its blade 15 cm long, while its handles are 7.5 cm long. So what is the mechanical advantage? So pair of a scissor has a blades. So length of the blade is 15 cm and length of the handles is 7.5 cm. This is for scissor. This is for pair of a scissor. Okay. Now for a scissor, if I draw a scissor like this, so for a scissor, here the effort is applied. Here we have fulcrum and here the load is there. So this load arm is 15 cm and this effort arm is 7.5 cm. So again, for this lever, the mechanical advantage will be again effort arm, that is EF, to the load arm, that is LF. Effort arm is 7.5, load arm is 15. So the value will be 0.5. Again, we are not having any unit for this as MA is a unitless quantity. This was question number 3. Now we'll solve question number 4. See, a force of 5 kgf is required to cut a metal sheet. So force of 5 kgf is required to cut a metal sheet. A shears used for cutting the metal sheet has its blade 5 cm long, while the handle is 10 cm long. So we have to calculate the effort is what effort is needed to cut the sheet. Okay. So force of 5 kgf is required to cut a metal sheet. So load is 5 kgf, then length of the blades. So blade length is nothing but load arm. So that load arm length is 5 cm and handle is nothing but effort arm, that is given 10 centimeter, right? So we have to calculate the effort required, E. Again, first of all, we'll calculate MA, that is effort arm upon load arm. So effort arm is 10, load arm is 5, so the value is 2, right? We have one more formula to calculate MA. Normal equation for MA is load upon effort. So value of MA is 2, load value is already given, which is 5, and effort value we have to calculate. So if we reshuffle it, it will be E is equals to 5 upon 2. So E will be 2.5 kgf. So in this way we have calculated the effort required to cut that metal sheet.